channel. We'll send out an email. There we go. If everyone just got the reminder of it's being recorded. So we'll send out a link later this week in your email. And so please feel free to share that with your circle. We have an hour today for our discussion with Dr. Moore. So in a few minutes, Erin Hill, the Executive Director of Watershed Watch, is going to join us to introduce Dr. Moore. His presentation will take about 30 minutes, and there will be some time after the presentation for questions. On your screens, you should see a Q&A icon, so you can submit your questions there, and we'll do our best to relay as many as possible to Dr. Moore. We probably won't get to all of them, but please submit them, and we will keep an eye on that queue. Just a reminder that Watershed Watch is a nonprofit organization whose mission is to defend BC's wild salmon. You'll see a donation link in the chat for today's webinar. So if you'd like to make a donation, know that help from supporters like you is what allows us to continue our work, and we're incredibly grateful. So last but certainly not least, people are joining us today from traditional Indigenous territories all over BC, and in fact, all over Canada. I think we have some people coming in from outside of province. Welcome. We at Watershed Watch are grateful to work closely with and learn from many of those nations in our mission to save BC's wild salmon for future generations. So thank you very much. Now it's my pleasure to hand things over to Erin.
Thanks, Deanie, and thanks everyone for coming. It's great to see this turnout, and yeah, great to see all these familiar names in the participant list. It really shows how much concern there is out there for the salmon and how they're weathering the climate storm. Excuse me. I'm joining you today from Victoria in Songhees and Esquimalt traditional territory, and we're very honored to have Jonathan Moore joining us today. Dr. Moore is a professor of biological science and resource and environmental management at Simon Fraser University in Vancouver, where he holds the Lieber Arrow Chair of Coastal Science and Management and leads the Salmon Watersheds Lab. And John completed his PhD at the School of Aquatic and Fishery Science at the University of Washington, and he's worked on salmon ecosystems from California to Alaska to British Columbia. And I've been a fan of John's for a long time, starting when we were both still students and he was completing his PhD research, excuse me, when he was completing his PhD research at the University of Washington, studying the ecology of salmon ecosystems in Alaska. And he's done a ton of impressive work since then. And I really appreciate how he and his team have consistently tackled the big, important questions that need answering. And they've done so to the highest scientific standards. And we asked Dr. Moore if he could speak on the issue of climate change in salmon ecosystems, because global warming is really now punching all of us in the face a little harder every season, and our salmon are experiencing those impacts too. It shouldn't be controversial to say that climate's now the biggest determining factor for most of our salmon populations, and most of the work we do here at Watershed Watch for wild salmon really can now be viewed through a climate lens. And by that, I mean that we're tackling the issues that we think will give our salmon and watersheds the best possible chance to survive and thrive in our warming climate. And in figuring out how we go about our work, we look very closely to some key leaders, scientists and policy experts for guidance on how we should be focusing our efforts for salmon. And John's one of the very best of those that we look to. And so that's why we wanted you to hear what he has to say. So John, thank you so much for doing this, and please take it away.
Thank you very much, Aaron. That was really kind and generous. Yeah, and it's an honor to be joining this event and a part of this conversation. It's going to take a moment and get my slides up and running. Just confirming that folks can see the full screen of the slide.
Yep.
Thank you. Well, again, wonderful to join you today. Really excited to have this conversation. And again, thanks to Watershed Watch for hosting this and putting this on. I'll say it's really affirming and heartwarming to think about connecting with you all. I see 190 participants, and I really love thinking about people connecting virtually, but connecting from their own watersheds and thinking about their own issues, but coming together for this common conversation. And thank you for making time in your busy day. I'm joining in from Simon Fraser University in Eastern Vancouver on the unceded territory of the Coast Salish peoples. So what I wanted to do just to start is to take us underwater. And this time of year, if you are in the right place in the right time, and you put on a mask and snorkel and you get in the river, this is what you might see. You might be surrounded by fish on their way home from their amazing journey back to the place where they were born. And these places, of course, are places of rivers and landscapes, but they're also places of people. And I think it's really critical that we really hold in our minds that these systems have been stewarded by Indigenous people for millennia. And so what happens to these fish is something we all care about, and it's also a matter of environmental justice and food security and of deep importance. I'm excited to have this conversation today. What my goal is to just highlight some of the thinking that my team and others have been doing on this overarching question of how can we best steward salmon watersheds given climate change and multiple stressors, the other aspects that we ask of these salmon watersheds. And so I lead the Salmon Watersheds Lab at SFU at Simon Fraser University, and we get a chance to work in really amazing places and just feel a lot of gratitude for those places and the people we get a chance to work with. Our work is fundamentally collaborative, and so we aim to work with the local experts, with the local folks that really know the systems, and also work with the people that think a lot about how to translate information into action. And a variety of sources support our work. And so I just wanted to really highlight some of the many different organizations that it's really wonderful to work with. So overall, the flow of the talk is going to be as follows. First, I'm going to discuss some of the thinking and findings about rapid change in these salmon ecosystems. How are these salmon ecosystems changing? And then I'm going to share 3 little vignettes about work that is really suggesting some opportunities for local actions towards climate resilience, trying to help these systems be able to adapt and cope with the oncoming changes. And these vignettes will come from estuary ecosystems, river ecosystems, and then systems with high glacial coverage. And then I'll end with some just closing thoughts. And I'm also excited for the conversation at the end, so I'll leave lots of time for questions. So the salmon life cycle is, simplified in this cartoon here, where salmon are born in fresh water, and then after a rearing phase that might last, not very long, they might go out immediately if they're pink or chum, or it might last up to several years if they're Chinook or steelhead in particular. And then they go out to the ocean, going out through the estuaries, sometimes stopping over there. And then the ocean is where they'll achieve much of their lifetime growth. So they'll leave fresh waters, this big to this big, and then they'll come back, these powerful creatures, and then they'll find their way home and they'll spawn and then they'll die. And across this life cycle, climate change is challenging salmon. And so you have this life cycle that unfolds across all these different ecosystems, and all these different ecosystems have different climate change impacts. Some of the obvious ones that are really sort of coming to the forefront in British Columbia watersheds are, for example, shifting flow regimes, the timing and the magnitude of how much water is in these rivers. And what we're seeing is that summer flows are getting lower in many watersheds as precipitation changes from snow to rain. And so is no longer these ice cubes on these mountains that then gets released through the summer. And so there's less water in many rivers during the summer. And there's also sometimes increased floods. So with big atmospheric rivers, you get increased scouring floods that could actually dislodge the eggs that are buried in the gravel or harm salmon in other ways. And so these flow regimes are changing, and they're changing, quite a bit from year to year as well. So we might have a dry year, we might have a wet year, and these are different pressures. The flow regime is this sort of, the heartbeat of rivers, and the salmon are adapted to that heartbeat. And so as this system gets changed, salmon are having to cope with that impact. Another obvious impact of climate warming caused by people is warming watersheds, or sorry, warming water temperatures. As the air gets warmer, water gets warmer as well. And in general, salmon prefer coolish water. On the right there is a simplified graph of water temperature and then the overall performance of salmon as a function of water temperature. And so if the water is hyper cold, then salmon, it's a little bit chilly for salmon actually too, and they might not swim as fast and they might not perform as well. And as the water warms up a little bit, they might actually do better. But then it hits a cliff. It hits this place where the water is just too warm and they're going to get more vulnerable to disease and they're going to really struggle. And at some point, they actually can go into cardiac arrest. And so with warming water temperatures, it depends on the river a lot, right? And so some systems, as you get pushed up this curve, then it actually might have a slight increase over in terms of the suitability of that habitat for salmon over the forthcoming decades. But in other systems, as the water temperature gets pushed over in a hot year, salmon are starting to die. And in the Fraser River, for example, we're starting to see many years where you have a substantial proportion of the fish just not making it back because the water is too warm. The salmon respond to these changes in complicated ways. And so one of these ways might be, for example, the timing of their life history events. One of those really critical life history events is when those young salmon, the smolts, migrate out to the ocean. The timing of this matters. And so if they hit an ocean at the time when the food web is right, then they're more likely to survive. But if they're mismatched from the timing of that ocean food web, then they're more likely to die. And there's a great project led by one of my former PhD students, Dr. Sam Wilson, and she compiled this amazing data set from up and down the coast of Western North America, from all these places where people are working really hard to try to figure out when salmon are migrating out to the ocean. So there's dozens and dozens of these monitoring places. This is hard work, and they're doing this year and year and year. And what Sam discovered by compiling all these different years and places with data is that in general, salmon migration for these young fish is getting earlier. Flowers are blooming earlier and salmon are migrating earlier too. And so this is just a symptom of climate change. But what was really surprising was it was remarkably variable, and that some populations weren't changing at all, and other populations were actually getting a bit later, maybe. And so you have this crazy diversity in how these local salmon populations are responding to climate change. Another key finding in this paper was that it seems like these changes might not be keeping pace with the ocean food web changes. So the ocean is also changing in terms of the timing when those tasty prey are blooming in the ocean. And it seems like that might be advancing more rapidly than the salmon populations. And so this is cause for concern. We might, given this finding, we might expect there's going to be some of these years where things are mismatched and more unpredictability in the ocean survival of these fish as climate continues to push the timing of these events forward in different paces. Another key life cycle event is the timing of when the fish come back to spawn. So it's a picture of a large Chinook salmon that we were working with in a local river around Lower Mainland. And these are the big, beautiful fish, one of the obviously the largest Pacific salmon species in North America. So the timing of when these fish come back to spawn is another really key part in their life. Again, they need to make this transition from the ocean where it's salty back to fresh water and migrate up, find their way home, and then maybe hold for a while and then spawn. So a grad student was interested in the timing of this across, again, the range of Pacific salmon. This is work by Anna Potapova. And what she discovered is shown here. And for me, I found it truly remarkable. So these data show the timing of when Chinook salmon, enter the river to go upstream to spawn from Alaska, shown in that salmon-colored points, all the way down to California, shown in the fuchsia or purple-colored points. And so each point is a different locally adapted population. So first of all, again, what just amazing biodiversity. It's incredible to think of how across the range of salmon, you have fish going upstream in June and July, like up in Alaska, but then you also have fish going upstream in February or November. So all these different unique populations that have solved their own challenges for their own systems and come up with their own solution. But the obvious pattern is also really striking, isn't it? Such that we have up north, the fish are going upstream when it's warm enough. They're going upstream during the peak water temperatures for the most part during the summer. But then as you get farther south, down into Washington, down into California, down into Oregon, you start to see this pulling of the life histories. You're starting to see populations coming before the summer water temperatures get hot or after the summer water temperatures get hot. And so what this demonstrates is that salmon have already come up with a lot of different solutions to this challenge of warm water temperatures during the summer. In California, in general, they come in before it gets too hot or after it gets too hot. The thing that's interesting to think about is if we play this forward, it gets important, even more important. So we have basically this zipper of climate change, right? So as things get warmer, it's going to further pull those life history timings apart. The ones that are earlier are going to get pressured to get earlier. The ones that are later are going to get pressured to come back later as the water temperature gets even warmer during the summer, as they need to avoid that water temperature even more. And one of the things that's interesting about this finding is that BC is right at that pinchy point of that zipper. BC is right where we predict these salmon populations to be diverging the most. So we should expect to see the timing change over the forthcoming decades. And we should also make sure that we're trying to give these fish a chance to adapt. And one obvious question that comes out of this is, will salmon be able to keep up with this? And if we do this back of the envelope calculation and we figure out, well, how many days per decade would the population need to come back earlier or later, given the pace of climate warming? How does that compare to observations of run timing shifts? And it looks like it's within the realm of possibility. And so in my mind, I was happy to see that. I was happy to see that it seems like within the scope of salmon's capacity to evolve and adapt based on their life history timing. There's a lot to be worried about with this. We need to give them the chance. We need to give them the space and the time to adapt, but there's reason for hope. And if we step way back, to me, this really affirms and showcases the real diversity and resilience of salmon systems, whether it's the fact that there's, spawning and migrating in these desert rivers of California or these coastal rainforests or way far north. They've coped with amazing challenges over their evolutionary lifetime, and they've found solutions. And so we have diversity of habitats, we have diversity of life cycles and life histories, and we also have genetic diversity. And all these pieces of diversity, of biological diversity, I think of them as puzzle pieces. I think of them as puzzle pieces to a challenge that we frankly don't quite understand how it's going to play out in these complicated systems. But by keeping these pieces, we can increase the chance that we have those into the uncertain future. Of course, these systems aren't just pressured by climate change. These systems are also having a lot of land use activities. We live in these systems, we work in these systems. And so there's this direct pathway also by which human activities are affecting salmon systems. And that the fact that there are these sort of dual arrows of climate change and human impacts means that we should probably be thinking about these things in concert. We should be thinking about how is climate change affecting systems, but then at the same time, how are human activities affecting the ability of these systems to change with climate change. So I'm going to share these 3 vignettes, starting on estuaries and then working up the watersheds. So as mentioned, estuaries are these places where young salmon have to migrate down through, and oftentimes they stop over. And it seems like growth during this time period is really important for their future survival. They can grow up and get a little bit big, and that helps them survive that hungry-mouthed ocean. Estuaries are also places that are highly sought after for development and other human activities. And so there is a lot of pressure on these systems, these stopover habitats. And one of the emerging challenges is what's framed as coastal squeeze, the idea that with sea level rise, these ecosystems are going to get squeezed between coastal development and that sea level rise. So in this cartoon on the top, what we have is a scenario where the ocean is rising, but the tidal marsh habitat may be able to adapt and migrate up the beach with that sea level rise. In the bottom cartoon, what we have is some coastal development, and there's going to be limited ability. There's not space for that ecosystem to go. And I'll note that one of the sort of key pieces of infrastructure in these sort of low river ecosystems and estuary ecosystems is dikes and floodgates and other sort of solutions that we try to have come up with for flood control. And for example, work by Dave Scott and Rebecca Seifert, former master's students in my group, really looked into what's called these floodgates, these one-way check valves on these systems. And what they discovered is that these are real hotspots for non-native species, but then also they have really low abundances of salmon compared to reference sites. And I just want to give a shout out to the Connected Waters campaign from Watershed Watch Salmon Society. As they're using this information and taking it to action, they're working on rehabilitating these systems to actually allow for them to be fish friendly as well as protect from flooding. And in these ecosystems, we do have substantial predictions of sea level rise, work by Smart Shores and others as part of the Estuary Resilience Project led by Nature Trust BC, is predicting large scale changes in sea level rise. And so here we have an estuary on Vancouver Island, and just some arrows I've thrown on here where we say, okay, if the sea level rises 25 centimeters or so over the forthcoming decades, it might be able to move up that system and adapt as the ocean rises. But in some places, because there's dikes or barriers there, it might be blocked. And so we've been working on this project collaboratively with others, trying to understand where salmon hang out. This is some imagery of myself and team doing that seining for fish, trying to understand the types of habitats salmon use now, and then looking into the future. And this project's very, very exciting because that knowledge is then translated into the on-the-ground restoration. And so Nature Trust British Columbia and partners, the many different rights holders in the area, they're doing this work. They're then, trying to do the restoration, the large scale, land acquisitions and barrier removals to try to get these systems more connected so that they can cope with oncoming climate change. So that's one vignette of opportunities for increasing the ability of these systems to cope with change. Another vignette is from the main stems of some of the salmon rivers. And so if we go to the interior of BC, those salmon systems might look like this, arid. They're working watersheds with agriculture and forestry. And one of the sort of the key drivers of salmon populations are those water flows and those water temperatures. Is there enough water for fish? Is it getting too hot? And it's important to remember that these systems aren't just affected by climate change, but they're also affected by land use. This is some time lapse of some forestry in an interior watershed of BC that does contain salmon populations that are really struggling. And work by others, as well as some in our group, has found that forestry can really have profound effects on those habitat conditions. And so if you perform clear-cut logging, the water temperature will increase about 2 to 5 degrees. That's a lot of increase. And then the low summer flows in the decades following forestry might decrease by around 25%. And so this is really important because these are the exact same symptoms of climate change that we're seeing in British Columbia as well. And so how much climate warming is the equivalent of clear cutting a system? It's a lot. And fundamentally, one of the things that science can do is it can identify, well, how hard can we push these systems maybe? And so work by Luke Warkentine, a master's student in the group, in that Nicola interior watershed, looked at this. He asked the salmon this question of, well, how much water is needed? And so looking back through time and asking the data, what describes whether that population is going up or down. And what mattered the most was the amount of water during the summer. And it mattered especially for the time when the young salmon were rearing. And so if there's not enough water, the habitat gets constrained and they don't do as well. And so that relationship is shown here. What we have is that, not surprisingly, when there's more more water, the salmon do better. There's more recruits per spawner. That means there's more babies per mother. And if it's above that one line, it means that population is increasing. If it's below, it means it's decreasing. And so what we found is that, yeah, salmon need water, but they actually need more water than we thought they did in this case. And so this type of information can help with some of these hard decisions about, well, how much water should we take out for agriculture? How much forestry should be allowed in these systems? So these are going to be trade-offs in these salmon watersheds, but the bottom line is that there is local agency. Climate change is happening. It's decreasing summer flows. It's also warming water temperatures. But these are also things that we can, turn the dial on through how watersheds are managed. And then Nicola, there's really exciting work going on, a G2G process with true leadership by the tribes, really trying to think about how do they want their watershed to look and how can it be stewarded into this climate impacted future. The last one yet I'm going to share is further up north in British Columbia and some of these places that have a lot of glaciers. We've all seen footage of this where we have these sort of shocking pairs of pictures where a landscape that used to be covered by ice is now water. And so these landscapes are being transformed. And depending on the climate scenario, between 60 and 100% of glaciers are predicted to be gone in Western Canada by 2100, depending on depending on the emissions scenario. And so with this glacier loss, there's a lot of cultural loss. There's a lot of loss for society, these icons, these places that have, real meaning to people. And that also poses downstream risks to ecosystems. You no longer have these sources of cool water during the summer. And at the same time, in some of these places, salmon are finding the rivers that are created as the ice retreats. And so as the ice retreats up these valleys and the rivers lengthen, salmon are finding these ecosystems and calling them home. So work by Sandy Milner and others from Glacier Bay, Alaska, for example, were observing one of these brand new rivers that appeared from under the ice in 1970, and the ice retreated. And, a couple decades later, there was over 10,000 pink salmon in the system. And so we've been looking into this, and amazing work by a former postdoc and now spatial analyst in the group, Dr. Kara Pittman, actually did this. She mapped out for the 46,000 glaciers that are across the range of Pacific salmon for Western North America. With their retreat, how much salmon habitat will actually be created. And I'm not saying climate change is good for salmon. There's all these harms, but there might be some of these opportunities in some places. And what she found, what she discovered, is that glacier retreat will create substantial amounts of rivers in some locations, especially in northwestern BC and the transboundary area, as well as southern Alaska. Over 6,000 kilometers of new rivers are predicted for salmon over the next 100 years. And it's kind of shocking to see this happen. It feels like so fast in our lifetimes. And so this is some footage or some pictures from one of the places that I work up in northern British Columbia, the Taku Watershed, in partnership with Taku River Tlingit and Flathead Lake Biological Station. And a picture taken in 2007 showed a valley filled with ice by one of our key collaborators, Mark. And then when our team retook that picture in 2019, we have this big lake, intimidatingly big lake, and we don't know when it's going to be colonized by sockeye, but it's going to happen soon. They're right there. They're chomping at the bit. So it's exciting to see, and also, frankly, horrifying to see these sort of systems get transformed by climate change, but salmon are looking to those changes for opportunities. These systems are also hotspots for mining, and so mining companies are also looking to the edges of ice for mineral deposits that haven't been explored yet. And so, for example, in 8 years of glacier retreat, at the rate it's been going, there could be an ore body sticking right out of the ground that no one's ever seen before. And so mining companies are actually staking claims on these habitats, and there's this upcoming, decision. Or should we steward these systems for salmon, or should they be allowed to be mined? And we are seeing this modern day gold rush in this region of northwestern BC and southern Alaska. There's, again, really exciting work, though, trying to look ahead and trying to think about, well, how should these systems be stewarded? And for example, the Gitnyaw First Nation up in the Nass and beyond, they have declared a new Indigenous protected area because they observed salmon, finding a new river with glacier retreat. And that river hadn't been protected, but they saw it, they witnessed it, and they declared that protection. So again, enormous agency towards stewarding the oncoming future of salmon systems. So I'm just going to end now with some large-scale thoughts, some ideas on paths forward. And these are, I think, the things that we can think about and things that we can do if we prioritize salmon futures. First is climate action for salmon. There's a need for taking action on climate change. Second, there's a real need to regulate land use for the resilience of these watersheds, for their ability to cope with change, whether it's forestry, whether it's estuary development, whether it's mining. And there are a lot of tools and policies out there. This is a life cycle of salmon with some of those laws and policies across that life cycle. And what you see is that it's a complicated landscape, and we need to make sure that salmon aren't falling between the cracks of these laws. Other important levers are fisheries and hatcheries. And this question of, in this era of change, how can we sustainably harvest salmon for economies, cultures, and food? And one of the things that we work on a little bit is thinking about, the reality that salmon fisheries, they don't always know what they catch. They're what's called mixed stock fisheries. And that fact is a very dangerous combination. So mixed stock fisheries and unpredictable returns caused by climate change is really hard to avoid over harvesting the weak stocks, the low abundance stocks. So in this cartoon, we have some different salmon populations in different colors, but this fisher accidentally over-harvested the blue population just by chance. So in this case, it would be, one fish, two fish, red fish, but no more blue fish because there was accidental over-harvesting. And so salmon fisheries are one of these levers that we can, manage quite closely if there's political will. And salmon will respond to fisheries management. And those fisheries pressures are occurring across the border. Alaskan fisheries harvest BC salmon as well. And if we step way back, one of the points that I just want to make again is I think we need to keep the pieces. I think we need this biodiversity for resilience, whether it's genetic or population or habitat, or even different ways of thinking, different ways of managing. But these are all solutions to this challenge that we're facing today. And the last point I make is that I think we need this collaborative and forward-looking science and forward-looking action. And I'm excited for this conversation to come because I imagine that many of you are working on things in your home watersheds, taking those actions that are needed to steward these systems into the uncertain future. Thank you for all that you do. And thank you for this opportunity to share this.
Thank you, John, for your excellent presentation. You've given us a lot to think about today, and I thank you for taking the time to do that. We have time now for some questions for John. So just a quick reminder to attendees that you can submit your questions in the Q&A section that you should see on your webinar screen. And if you see a question you want us to ask, you can bump that up in the queue by liking it. So we probably won't have time for everyone's questions. We'll get to as many as we can. And just to start us off, John, I want to ask you, what are the areas of BC of greatest concern in terms of salmon species showing more advanced stresses due to climate change?
Yeah, thanks for that. Many of the places where we're starting to see real acute signs of climate pressures are, some of the more southern parts of British Columbia, and also some of the places that do have human activities that compound those climate risks. And so that's the sort of general answer. The fact, though, is that there's a lot of places throughout the province that are already seeing pressures. And so even up north, there are systems that are getting really warm and seeing harm caused by climate change in some years. So there's a lot of diversity. And, I think we really need to sort of keep our eyes on the stocks. We need to keep our eyes on the status of these populations, given the fact that there's so much diversity in climate harms and climate impacts.
Well, ditto on the thanks, John, for the excellent talk. I was going to ask a question on, the importance of maintaining the diversity of salmon to preserve that ability for them to respond and be resilient to changes. And I was thinking about fisheries, and I was thinking about hatcheries and how they interact. I was just wondering, if you have thoughts on how, our hatcheries, is a tool that's being used for conservation in some cases, but also to support fisheries, and how those things interact, and how we can manage them to ensure maximum diversity for our fish.
Yeah, it's a great question, and a tricky one too. It's a hard one. So in general, if we think about how fishing systems are, need to think about climate change, what we're seeing is returns are more unpredictable, right? And so we no longer have quite as good ability to sort of predict how many fish are going to come back. And so what that means is that we either need to fish less, or we need to be sort of more responsive to the shifting returns and sort of unpredictability. Now, the thing that's of sort of real concern that you alluded to is that we oftentimes turn to hatcheries when things are struggling, and hatcheries allow us to keep fishing, usually. And if that is the case, then we actually keep hammering on the remaining wild fish. And so the use of hatcheries, I think, needs to be done with extreme caution in these situations where we're looking to also harvest a lot of fish, if there's co-occurring wild fish. So that's, I think, one of the key take homes for me on that point, is just being very careful with hatcheries, and also being very sort of thoughtful about what the goals of those hatcheries are. Is the goal to connect with the public and connect with school kids and show them the salmon life cycle? And hatcheries are amazing at that. Is the goal of the hatchery to support a local fishery? Or is the goal of the hatchery to conserve that population? Or is the goal of that to support a large scale fishery? And it's not clear that hatcheries can sort of do all those at the same time. And so it's oftentimes important to try to align the goal of the hatchery with the sort of action of the hatchery. And again, just being really careful with them if we're trying to ramp up harvest, because that what that'll do is it'll ramp up harvest on the co-occurring wild stocks. Yeah.
Thank you, John. Just looking over to our Q&A, and so we have a question coming in from Greg, who asks, are the salmon stocks skewed straying to newly opened glacial streams coming from endangered or healthy runs?
That is a great question. We don't know the answer to that. I think what we're seeing in the Taku, at least, is a lot of river type sockeye. And so river type sockeye, unlike lake type sockeye, seem like they stray a lot. And so they probably are adapted to finding these new systems, these new dynamic river systems. So that's a sort of simple answer. There's also coho in there. And so I think the salmon that'll find these populations at first are the life histories and the species that are sort of adapted to find new habitat. And we don't know where they're coming from, and we don't know what sort of genes are coming with them. I think a huge scientific question that's also really important is trying to understand, if we're looking for salmon to adapt, where are those adaptations coming from? And we might actually need to be thinking about our salmon from our south. They might be the salmon of the future from up here. And so, we might be relying on southern populations bouncing up north over time to bring some of those genetics up north. On the other hand, there's a capacity of these systems to just rapidly evolve if there's high genetic diversity. So that's a huge scientific uncertainty, and I think one that's really fascinating and really important given climate change. And we don't know. We don't know, at these sort of new places where these fish are coming from and how this is playing out. But really fascinating and important.
Thanks, John. We have a upvoted question here around salmon farms, and I think there's a lot of folks really concerned about the impact of salmon farms on salmon, and it's an issue that we work on a lot. We're trying to ensure that our salmon aren't exposed to pathogens from openness fish farms on our coast as they make their way out to the sea in that very vulnerable stage of their life. But I'm wondering how viruses, parasites, et cetera, from salmon farms, sort of, if you have any thoughts on how they might interact with the pressures of climate change throughout their life cycle.
Yeah, that's a great question. And there's a building body of scientific evidence by others, not myself, that's really sort of uncovering all these different pathways by which salmon farms can harm wild populations that are migrating through the coastal waters. And as you mentioned, they can include viruses. They can also magnify local pathogens and parasites like sea lice. And it's just one more hammer on salmon populations. It's another pressure on these populations. And so there's, a lot of good work on this, and also some exciting action happening in terms of getting some of these salmon farms out of some of those key migration pathways, and just really applaud the work that's making that happen. And, based on what I've seen from the data, we should expect that should help some of these populations in those areas as they are no longer harmed by those farms quite as much.
Thank you for that. We have a question from Oliver, who's asked if there were only one policy or legal shift in this province, what would help salmon the most?
That's a great question. Thanks, Oliver. My brain, I'm biased, but I really am worried about the sort of death by 1,000 cuts. I'm worried about all these different activities, and they're all sort of contributing some to harming salmon ecosystems. And we're lacking legislation to track that. And so in my mind, I would love to see some of the cumulative effects processes have legal teeth and have the capacity to actually say, okay, that's too much, no more here. And so there's some really exciting work happening on that forefront, as I know that Oliver, and that you're sort of involved in as well. But in my mind, I think the sort of policy legal shift that I would love to see is the cumulative effects side of things. And I'll say that I was really excited to read the province's draft biodiversity and ecosystem health framework. They did mention cumulative effects, and they sort of set out, really positive vision for shaping, BC's approach to stewarding natural systems. And I think there'll be a lot of work to move that towards reality. Yeah, great question.
Yeah, ditto. That's a great question. So we have a question about the zipper analogy. Are there salmon species that are not adapting using the zipper analogy? And are there some species that might, I'm going to embellish this a little bit or add to it, are there species that might fare better or worse, with the zipper squeeze that you described?
Yeah, we haven't looked, is the short answer. I think sockeye, we probably will see the same zipper, the same bifurcation of run timing. That's what's been found in some previous work from a while ago. What's kind of unique to what's unique to Chinook that we studied and sockeye is that they do have these sort of extended rearing phases, or not rearing, staging phases as adults. And so like those early runs, they'll actually hang out in fresh water until they'll spawn. They'll spawn in the fall, even in that. So they might hang out in fresh water for 6 months. And I think that has limits, right? You can't as you pull those populations away from their spawn timing, it's going to be harder and harder for them to go for that whole amount of time and not eat the whole time and still successfully reproduce. So I think that zipper has limits, and the more we pull, the harder it's going to be. Across the species, I think it's a great question. I think we don't know. I think the different salmon species seem like they're differently vulnerable to climate change across the different stages of their lives. And this is something that I don't think is really has scientific consensus on by any means, but my own personal sort of read of how things are playing out is it feels like pink salmon are doing pretty good in many cases. They're kind of the rats. I love pink salmon, but they're kind of the rats of the salmon world. Short generation time, very prolific. They can spawn in a lot of places. So I wouldn't be surprised if they're kind of climate change winners in the salmon world. I do worry about Chinook. They seem like they're struggling across their range, in part because of salmon, because of climate change, but then other pressures as well. So I think we're going to see some winners and losers, and I don't think we quite know yet, but that's my hunch in terms of how some species might be more vulnerable or less vulnerable.
Yeah, that makes a lot of sense. And there was another question I saw that was upvoted about the spread of pink salmon, how they're really colonizing up into the Arctic, and is that climate related?
Yeah, so my understanding of that, but we obviously haven't studied that directly, but from talking to others that have, is that they are starting to see Chalm and pink farther north from where they've seen them. And also, over in Northern Europe, they're starting to see pink salmon coming in from Russia as well. So salmon are spreading in that sort of northern range boundary, and it does seem like it's likely climate related in some places. I'll say that, it's interesting talking to some of the sort of local rights holders there, and some of them are excited and some of them aren't excited. Some of them are worried about their local char populations and aren't that happy to see salmon into their systems. So, these changes that we're sort of witnessing are challenging cultures and they're challenging places.
Thank you. We have a very good question coming in from grade 5 student Kim, who would like to know, how long have you been doing your job for?
Thank you, Kim. I think this is gonna make me feel old, but I've been a professor for about 18 years. But I've studied salmon for a long time, and actually I sort of grew up, it's hard to know when it started because I grew up fishing a lot and grew up hiking the streams and, experiencing these places with my family. And so I kind of feel like it started when I was in grade 5 or something like that, but just like falling in love with these systems and trying to understand them. And then, I first started, actually working as a job when I was in college. So it was a few years ago. But yeah, fun question. Thank you.
So Rosemary and others are asking if you can comment on the impacts of Roberts Bank Terminal 2 on the Fraser River estuary and salmon populations there.
Yeah, thanks for that comment and question. It's a important topic, obviously. It's not something that I've directly engaged with. I worry a lot about big industry projects in estuaries, and that's sort of my bottom line. There's extensive work that finds that when estuaries are more degraded, salmon do more poorly. And you start building more, and there's just all these different pathways of harm. And so I do worry about it, and I wasn't directly engaged, and so I can't speak to the details, but I do worry about it.
And just, I guess, following up on that, I know you did some really important work in the Skeena estuary around the proposed LNG terminal, and that would have destroyed Flora Bank. And you'd expect the same sort of processes to be playing out there?
Yeah, exactly. And so, one of the things that's pretty hard to wrap one's head around, but these estuaries are really they're the base of these amazing watersheds. And so what the Fraser River is 220,000 square kilometers, I think. So that's the size of the United Kingdom. And it's got hundreds of locally adapted salmon populations from all species. And they all go through the same estuary. And so you have this sort of gathering place where some populations stop over and rear and really sort of rely on these systems as they move out. In the Skeena, what we found working with Loch Lom's and others is that you do the genetics and you do find lots of different populations from the Skeena and beyond. One of our collaborators called it Grand Central Station for salmon. And we also found that some places were particularly important for salmon. And that was, in this case, as Aaron alluded to, the location where a proposed LNG terminal was proposed for. And in the end, it was not advanced. And so that place was protected. And it's hard to see other estuaries change.
Thank you, John. I think we have time for one last question before we wrap up here. So just want to ask you, one of the big challenges right now is combating climate fatigue. And that's this sense that it's too late, we've left it too far, and there's nothing to do now. But that's not what I heard from you today and about your research and what you found out there. So what do you hope people take from your work and from your presentation here today?
Yeah, thanks. Well, I hope that one of the key take homes is that salmon are resilient. They've adapted to a lot over their life cycle, and they do have the capacity to cope with change. And that being said, we're asking a lot of them. We're asking a lot of their ecosystems. And I think that there's, we need to shift that. If we want them to keep pace with change, there's a lot we can do. And so that's another sort of second key point is there's a ton of local agency. Yes, we need to take action for climate change. And then yes, we need to think about how we're using these watersheds, using these systems, and thinking about the future. How are they changing and how can we allow them to change in a good way? So I guess I hope that people are left with a sense of urgency and also a sense of hope and also a sense of resolve.
Great, thank you. We actually probably have time for one more. So I did see this, the Daniels family asked, do you have any actionable suggestions of what we can do to help, organizations we can volunteer at as a family with kids, or things we can do on a day-to-day basis? And they thank you for your presentation.
Thanks for that question. Yeah, I think not to get too insular, but I really recommend sort of thinking about Watershed Watch as a group to connect with, and other sort of local, grassroots groups as well. I think the sort of local watershed stewardship groups are great, and get engaged. And so I really appreciate that question. And I think, look at, do some reading, find some organizations, and start getting the boots wet.
So I think that is probably most of our time for questions. Thank you so much, John. And I'll pass it over to you, Aaron, for some final thoughts.
Great. Yeah. Thanks again, John. And thanks everyone for your great questions. And there's a lot of great questions that got asked that we didn't manage to get to. So we're noting those, and we'll keep those in mind as we, put out blog posts and social media posts over the coming weeks to tackle some of the things that it's obvious people are curious about. But yeah, that was just a fantastic talk and discussion, and I really appreciate everybody taking the time for this, and especially Dr. Moore. I also wanted to give a special shout out to those of you who support our shared work for wild salmon with your donations and advocacy. Yeah, John, I just wanted to actually just pause. I was going to pause earlier, but just to see if you had any final remarks.
Just to thank you and your team for this connection, all your work, and also the audience. I just really am heartened to imagine people connecting in from afar and thinking about their own places and the work they're doing. So thank you for your time, everybody. And again, thanks, Aaron and team.
Yeah, thanks, John. And so I just wanted to also say that there's, to follow up on that last great question, especially, there is a lot we can do to ensure that there's salmon around for our kids and their grandkids. And I'm just going to mention a couple of things that we're doing right now. We can get hundreds of thousands, maybe millions more salmon back into our rivers every year by tackling the mixed stock interception fisheries that are occurring in Southeast Alaska that are really hitting BC salmon hard. That's an issue we're working on. We can make sure all of our salmon can enter the Pacific Ocean without being exposed to parasites and viruses from salmon farms. we can protect and restore critical habitats, especially in the lower river and estuary areas that John was describing the importance of. And this stuff is all doable, but it's a lot of hard work. There's a lot of forces arrayed against us, and anything you can do to help is important. So, sharing knowledge with your friends and family, getting involved in the ways that John described with local stewardship groups, write to your MP and your MLA, better yet, go and meet with them in person, and describe your concerns about salmon and the solutions that you'd like to see, and donate if you can to groups like us. And I think if somebody, Megan or Deanie, if the donation link isn't in the chat, you could maybe drop it in there, and get in touch with us if you want to do more. So yeah, thanks again, everyone. Thanks to Megan and Deanie for pulling this all together, and thanks again to John for the talk and the great work you're doing, and to everyone for joining us today. Take care.
Thank you, everyone. That link is there. You can also find it on our webpage. Thank you all for joining us. Have a good day.